Hello everyone. In this video we will discuss about Cayley-Hamilton theorem statement and its example. See, Cayley-Hamilton theorem is also called what here? CH theorem. Statement is every square matrix satisfies its characteristic equation. Means in this what you should do first? You have to find out the characteristic equation. After finding the characteristic equation, you need to satisfy that characteristic equation. How to satisfy that characteristic equation? You have to show left hand side value is equals to what here? Right hand side value. So one example I'm going to consider here. In this example, you will get to know how to verify CH theorem or Cayley-Hamilton theorem. See, example is if A is equals to one square matrix is given 1, 2, 3, 4, then verify Cayley-Hamilton theorem. So to verify Cayley-Hamilton theorem, first you need to find out what here? Characteristic equation. Therefore solution, you know the formula, correct? So let determinant of A minus lambda I is equals to 0. Next, determinant symbol, keep it as it is. Next, what to do? For this principal diagonal elements, subtract lambda. 1 minus lambda and here 4 minus lambda. And remaining these two terms, keep it as it is, 3 and here 2 is equals to what here? 0. So now it is in the second order determinant form. So apply second order determinant rule. So cross multiplication, middle negative sign. So 1 minus lambda into 4 minus lambda, middle negative sign, 3 into 2 is how much here? 6 equals to 0. Open the bracket. 1 into 4, 4. 1 into minus lambda, minus 1 lambda, minus into plus is minus lambda into 4, 4 lambda, minus into minus plus lambda into lambda goes to lambda square, minus 6, keep it as it is, equals to 0. So in this entire equation only one lambda square is there. That lambda square I am going to keep it first. Next here minus 1 times of lambda, minus 4 times of lambda, minus it is 5 times of lambda. Next 4 minus 6 is minus 2 is equals to what here? 0. So this is the characteristic equation. So now you got what? Characteristic equation. So next step you need to satisfy this characteristic equation. So to satisfy this characteristic equation, so what they are going to do in this equation, wherever lambda is there, that lambda they are going to replace by what? A. So next step, put lambda is equals to what here? A. If I take lambda is equals to A, then this above equation becomes A square minus 5A minus this constant term I am going to multiply with what here? I is equals to 0. So later on I will tell why you need to multiply purely constant term with the identity matrix. Okay, so what to do? After finding characteristic equation, wherever lambda comes you have to substitute, that is lambda is equals to what here? A. Why you need to substitute lambda is equals to A? Because you are going to satisfy what? Characteristic equation. See, in this only you know A value. A matrix already they had given. What is A matrix given? 1, 2, 3, 4. But you don't know which value here? Lambda value you don't know, correct? Lambda value you don't know. That's why what they are going to do to satisfy this characteristic equation, after finding the characteristic equation lambda is equals to, they are going to replace by what? A. So lambda square becomes A square, 5 lambda becomes 5a, and this purely constant term you have to multiply with what? Identity matrix is equals to 0. This later on I am going to tell why you need to multiply what? Identity matrix. Call this as equation number 1. So now you have to show this left hand side value is equals to right hand side, means entire this left hand side value, if you simplify, final answer you should get how much here? 0, correct? So to prove this left hand side value, first you need to find out which value? A square. Second, you need to find out what here? 5a value, and finally you need to find out what here? 2i. Okay, so first I am going to find out a square value here, correct? So a square is equals to, so you know a square can be written as what here? A into a into a. So is equals to a. Already a is given. So what is the value of a here? 1, 2, 3, 4. So 2 times you write here. 1, 2, 3, 4 into again a. 1, 2, 3, 4. A into a. So in between these two multiplication sign is there, so multiplication rule you apply. So which is equals to 1 into 1 is 1, middle always plus sign. 2 into 3 is 6. Next, first row second column, 1 into 2 is 2 plus 4 into 2 is how much here? 8. 2 into 4 is how much here? 8. Next, second row first column, 3 into 1 is 3 plus 4 into 3 is how much here? 12. Next, 3 into 2 is 6 plus 4 into 4 is how much here? 16. 4 into 4 is how much here? 16. So which is equals to 1 plus 6 is how much here? 7. 8 plus 2 is how much here? 10. So next, 12 plus 3, 15. 16 plus 6 is how much here? 22. 22. This is the regular method, or else you can use the box method also, correct? So here box method also I am going to solve. So what you are going to do? You are going to do here a square value. So in this part what I said, first matrix only rows you need to note down. First row is 1, 2, put one line. Second row is how much here? 3, 4. 3, 4. So next, in this part what to do? Second matrix column you should write. What is the first column here? 1, 3, put one line. Second column is 2, 4, put one line. Okay, so in this part, whichever the first matrix will be there, that matrix only rows you need to note down. First row is 1, 2, second row is 3, 4. In this part, second matrix only column you have to write. What is the first column? 1, 3, second column 2, 4. Next, multiply these two, keep it here. 1 into 1, 1, plus into plus is plus, 2 into 3 is how much here? 6. 1 into 2, 2, plus into plus is plus, 4 into 2 is how much here? 8. Next, 3 into 1, 3, plus into plus is plus, 4 into 3 is how much here? 12. So 3 into 2, 6, plus into plus is plus, 4 into 4 is how much here? 16. So next what to do? These all 4 values keep it as it is in matrix form. Therefore a square is equals to, in matrix, first one is 1 plus 6, second 2 plus 8, third one 3 plus 12, fourth one 6 plus 16, correct? So next add. Therefore 1 plus 6 is 7, 8 plus 2 10, 3 plus 12 15. Next 6 plus 6 is how much here? 22. 22, correct? Any one you can use. If you know the regular method, use the regular method. If you know the box method, you can use the box method. Both are same. Therefore finally a square value 7, 10, 15, 22. So finally you got a square value 7, 10, 15, 22. So this a square value is over. Next you need to find out only 5a. Don't consider the negative sign, only find out 5 into a value. Therefore here 5a is equals to this 5. I am going to keep it as it is. A means given matrix. What is the given matrix? 1, 2, 3, 4. Multiply 5 into 1 5, 5 into 2 10, 5 into 3 15, 5 into 4 20. This is the value of what here? 5a. So now you got a square value, you got 5a value, and last one you need to find out which value? 2 into I. Don't consider again negative sign, only find out 2 into I value. So 2i is equals to 2 into I means which matrix here? Identity matrix 1 0 0 1. Correct? Identity matrix means 1 0 0 1. So now multiply, which is equals to, so 2 into 1 2 0 0 2. Okay, 2 into 1 2, 2 into 0 0, 2 into 0 0, 2 into 1 2. So now you got all three values. A square value you got, 5a value you got, 2i value you got. So now consider equation 1. So what is the equation number 1? A square minus 5a minus 2i equals to 0. From 1. A square minus 5a minus 2i is equals to 0. Next, substitute a square value. So what is the a square value you got? 7, 10, 15, 22. Next, minus, keep this minus sign as it is. Next, 5a value. So here it is 5a. 5, 10, 15, 22. So 5, 10, 15, 20. Sorry, 20. Okay, 5, 10, 15, 20. Next, negative sign. So keep here negative sign as it is. Next, 2i value. What is 2i value? 2, 0, 0, 2. Equals to 0. So equals to 0. Okay, therefore, next. Now, here 3 matrix you got. Here you need to subtract the value. So you know the rule while adding or while doing the subtraction, always first element you have to add with the first element, or first element you have to subtract with the first element. So here 7 minus into plus is minus. Next, first element is 5, minus into plus is minus. So next one is 2, first element. Next, second element 10 minus into plus is minus. 10 minus into plus is minus 0. Third element 15 minus into plus is minus 15, minus into plus is minus 0. And last 22 minus into plus is minus 20. Next, minus into plus is minus 2, which is equals to 0. Okay, so next add and subtract. Therefore finally 7 minus 5 is 2. 2 minus 2 is how much here? 0. 10 minus 10 is how much here? 0. 15 minus 15 is 0. 22 minus 20 is 2. 2 minus 2 is how much here? 0. So which is equals to 0. So finally which answer you got? Sorry, left hand side value is equals to what here? Right hand side value. LHS is equals to what here? RHS. Hence CH theorem is going to verify. So now question is, suppose if you not multiply this purely constant term with I, what will happen? See, if you not multiply this 2 by I, in this part you will get only the value of what here? 2. See, first one is what here, 7, 10, 15, 22 I am going to write, minus 5a value is how much here, 5, 10, 15, 20 I am going to write. So here a square minus 5a minus 2 is equals to 0. Suppose if you not multiply this 2 by identity matrix, that time what will happen here, only you need to write which value here, 2. Suppose if you write only 2 here, it is not possible to add and subtract the values. So that's why what to do, for every constant term you have to multiply with the identity matrix. Identity matrix value is 1, 0, 0, 1. So keep it in mind. So this is very important part. Therefore, whenever you are replacing lambda is equals to a, after replacing lambda is equals to a, then this purely constant term you need to multiply with what here, I, then only final answer you will get what here, 0. Once you get left hand side value and right hand side value both are 0, that is LHS is equals to RHS. Hence you have to write what here, CH theorem is verified. Hence CH theorem is verified. So this is how you need to show. Next example. Verify Cayley-Hamilton theorem for the matrix A is equals to 2 minus 1 first row minus 1 to second row. Solution. So first again same, write down the formula. So you know, let determinant of A minus lambda I is equals to what here, 0. So next, determinant symbol, keep it as it is. So for principal diagonal element, subtract lambda, 2 minus lambda, 2 minus lambda, and remaining these two keep it as it is, minus 1, minus 1. These two elements keep it as it is equals to 0. Apply second order determinant rule, cross multiplication, these two values again keep it as it is, 2 minus lambda into 2 minus lambda, middle with sign minus, minus into minus goes to what here, plus 1 into 1 is 1 is equals to 0. Open the bracket, 2 into 2, 4, 2 into minus lambda minus 2 lambda, minus into plus is minus, lambda into 2, 2 lambda, minus into minus is plus, lambda into lambda goes to lambda square. Next, minus into plus is minus, 1 is equals to 0. Again here only one lambda square is there, that lambda square I am going to keep it first, lambda square. Minus 2 lambda is minus 4 times of lambda. Next, 4 minus 1 is how much, plus 3 is equals to what here, 0. So you got characteristic equation. Once you get the characteristic equation, next step what to do, you have to replace. So put lambda value is equals to how much here, a. Wherever lambda comes, you have to replace by what here, a. Therefore this above characteristic equation becomes a square minus 4a plus what I said, for this purely constant term you have to multiply with what, identity matrix is equals to what here, 0. Call this equation number 1. So next you need to find out 3 values, a square value, 4a value, 3i value. So first I am going to consider a square. A square is equals to a into what here, a. Correct? So is equals to a. So what is the a value? 2 minus 1 minus 1, 2. 2 minus 1 minus 1, 2 into 2 minus 1 minus 1, 2. So first regular method I am going to apply. First row, first column, 2 into 2, 4, middle plus sign, minus into minus is plus, 1 into 1 is 1. First row, second column, 2 into 2, 2 into minus 1 is minus 2, minus, so middle always plus sign, minus into plus is what here, minus, 1 into 2 is 2. Next, second row, first column, minus into plus is minus, 1 into 2, 2, middle again positive sign, again plus into minus is minus, 2 into 1 is what, 2. Next, second row, second column, minus into minus is plus, 1 into 1 is 1, middle positive sign, 2 into 2 is how much here, 4. So which is equals to 4 plus 1, 5, here minus 2, plus into minus is what, minus 2, here minus 2, plus into minus is minus 2, 1 plus 4 is how much here, 5. Therefore, a square value how much you got, 5 minus 4, here minus 4 and here 5. So this is the value of what here, a square. So this is the regular method. Otherwise, box method also I am going to show any one, whichever you feel easy, any one method you can apply. See, for box method, draw 2 lines. Okay, so you are doing a square. So this is the first matrix. So in this part, what to do? First matrix, only rows here to write. What is the first row? 2 comma minus 1. After that, put one line. Second row, minus 1 comma 2. Next, in this part, what I said, second matrix, only column you should mention. What is the first column? 2 comma minus 1. What is the second column? Minus 1 comma 2. Next, multiply. 2 into 2, 4, minus into minus plus, 1 into 1 is 1. So here, while multiplying, whichever sign you will get, no, that sign only you mention. So in regular method, middle always plus sign comes, but in box method, while multiplying, whichever sign you will get, no, that sign only you have to mention. So next, 2 into minus 1 is minus 2, minus into plus is minus, 1 into 2 is 2. Next, minus into plus is minus, 1 into 2 is 2, plus into minus is minus, 2 into 1 is 2. Minus into minus is plus, 1 into 1 is 1, plus into plus is plus, 2 into 2 is how much here? 4. Therefore, a square is equals to, in matrix form, all these 4 values, keep it as it is. 4 plus 1, minus 2, minus 2, next minus 2, minus 2, next 1 plus 4. Therefore, finally, a square is equals to 4 plus 1, 5, here minus 4, here minus 4, and 1 plus 4 is how much here? 5. So any one method you can do. So this is the box method. So you got a square value. Next, don't consider the negative sign, only find out which value, 4a. 4a is equals to 4 as it is into a value. So what is a value? 2 minus 1, minus 1, 2. Multiply. So is equals to 4 into 2, 8. 4 into minus 1, minus 4. 4 into minus 1, minus 4. 4 into 2, 8. 4 into 2, 8. So you got 4a value. And finally, which value you need to find out? 3i. So 3i is equals to 3 into identity matrix is 1 0 0 1. 1 0 0 1. So which is equals to 3 into 1 is 3 0 0 3. 3003. So you got all three values. Now write the equation number 1. Therefore from 1, so what is 1 here? A square minus 4a plus 3i. A square minus 4a plus 3i is equals to 0. So first note down a square value. Therefore a square is equals to 5 minus 4 minus 4 5. This is the a square. 4 minus 4 5. Next minus sign, keep the minus sign. Next 4a value is how much? 8 minus 4 minus 4 8. Next plus sign. Next 3i value is 3003 is equals to 0. Next add and subtract now. So in matrix, first element 5 minus into plus is minus 8. Next plus into plus is plus 3. Next minus 4 minus into minus is plus 4 plus into plus is plus 0. Next minus 4 minus into minus is plus 4. Next plus into plus is plus 0. Last element 5 minus into plus is minus 8 plus into plus is plus 3 is equals to 0. So now add and subtract. 5 minus 8 minus 3 plus 3 0. Minus 4 plus 4 0. Minus 4 plus 4 0. 5 minus 8 is minus 3 plus 3 is how much here? 0 is equals to what here? 0. So finally what you are getting? Left hand side value is equals to what here? Right hand side value. Hence CH theorem is verified. Hence CH theorem is verified.